All right, so here are the solutions to our bell work on our Unit 5, Day 1. So we had actually covered Unit 5 a little bit before break and before our finals. So we're actually going to take today and Wednesday to go over the two lessons that we have covered just as part of review, as it was pretty brand new the first time we covered it. So hopefully going over it again here will help us understand what we're doing a little better. All right, so we need to graph our linear equation, y equals negative 3x plus 8, okay? And then we're going to find out which of those ordered pairs is a solution, okay? So I graph my y-intercept first, which is 8, and then my slope is negative 3 over 1, right? So whatever is in front of your x. So I go down 3, right 1, okay? Do that a few times, right, until it goes off of the graph. Down 3, right 1. All right, we want to take up, fill in as many of those points as we can. So now I'm going to graph my two ordered pairs and find out which one of those ordered pairs, or both or neither, fall on the line that we just plotted, those blue dots. So I'm going to plot these points as red dots. So I'm going to go 4, negative 4, right 4, down 4. That was an overlapping point. So 4, negative 4 is a solution. The point 4, negative 4 would fall on that line. Now I'm going to graph negative 1, 5, so I'm going to go left 1, up 5. And that point does not fall on the line, so that is not a solution. Okay, we're just looking for which of those points fall on the line. Okay, that determines if it is a solution to the linear equation or not. Okay, number 2. Let's graph our linear equation. Our y-intercept is negative 4, and our slope is 1 over 2. So rise 1, run 2. Once again, let's do that a few times. Rise 1, run 2. And we can go in the opposite direction. Instead of rising 1 and going right 2, we can go down 1 from our y-intercept and left 2. Down 1, left 2. Down 1, left 2. Right? Our line extends infinitely in opposite directions. And then now we check our two ordered pairs. 0, 8. 0 is the x, right? First number in the ordered pair is our x. So I go right or left 0 and then up 8. So that point does not fall on either of those red dots, does not fall on the line. It is not a solution. And then I'm going to graph 8, 0. I'm going to go right 8 and stay there. And that point does fall on the line. So 8, 0 is a solution. And number 3, last one. Let's graph x equals 8. If we have just x equals a number, okay, that's one of our special equations. If it's x equals a number, that means our slope is undefined. It should be a vertical line where x is 7. Now, this is the only time we do not put our first dot on the y-axis, is because it's not telling me y equals. It is saying x equals 7. So I put a dot on the positive 7 of x, and if it is a undefined slope, our line is vertical. And then now I just need to graph my 2 points, 7, 6. So I go right 7, up 6. And that point falls on that blue line, so that is a solution. And then if I graph 3, 7, I'm going to go right 3, up 7. That point does not fall on that line, so it is not a solution. And those are the answers to our bell work. All right, I'm going to find our notes here. Okay. So hopefully you've had your notes passed back to you. All right, and we're going to go over our notes, and our homework and our bell work will be very similar to these types of questions, okay? We need to determine if the given ordered pair, in this case, in number 1, it's 5, 4, is a solution to the system of linear equations. So what we need to do is test to see if when x is 5 and y is 4, right, our x, y, does it work when I substitute those two numbers into both equations? Okay, if my left and my right side of the equation balance each other out, which means they equal each other, yes, they do form a solution. If they do not, okay, if it doesn't work for both of them, okay, it is not a solution. It has to work for both. So what I'm going to do is I'm going to take this 5 and plug it in here because that's what x is, right? X is 5. And then I'm going to take this 4 and plug it in there for y. And then I'm going to do my math. So my problem says negative 4x. What's happening to negative 4 and x when they're together? They're being multiplied. Well, I just found out x equals 5. So I'm going to take negative 4 times 5. And then I'm just using my equation after the x is plus 3 times y. Well, y is 4, so I'm substituting 4 in for y. And all of that should equal negative 8 if it's going to be a solution. So now all we have to do is put this in our calculator. Negative 4 times 5 plus 3 times 4. That gets you negative 8. And negative 8 equals negative 8, so it's a yes. Oop, I should have put that by this one. It's a yes for the top equation, but if this is going to be a solution for this system, it has to work for both equations. So in the bottom equation, I have negative x. Remember, if there's a negative right in front of the x, let's sneak a 1 there so we realize it's a negative 1 times x. And we're going to substitute what we can into this equation. I'm still using my 5, 4 ordered pair. Okay, our x is 5, so I'm going to put that right there. And it means negative 1 times x. Well, x is 5, and it should equal 5. Well, negative 1 times 5 is negative 5. Does negative 5 equal 5? The answer is no. So because plugging 5, 4 into our both equations, and it did not work for one of them, it means it is not a solution. It would have had to work for both equations for it to be a solution to that system, which means both of those equations. Okay, moving on to number 2. My ordered pair is 4, 2. Remember, it's x, y. So anytime in these equations I see an x, I'm substituting a 4 in its place. Anytime I see a y, I'm substituting a 2 in its place. So this 4 is going to go there. This 2 is going to go there. Okay? So negative 3x means negative 3 times x. What is x? X is 4. Just using my equation, plus 3 times y. What is y? It is 2. And all of that should equal negative 6. Once again, you can just use your calculator, type that in exactly as you see it. Negative 3 times 4 plus 3 times 2. Your answer, when you do that correctly, should be negative 6. And does negative 6 equal negative 6? That is a yes. So now we need to test it to the bottom equation. And if this works out, and it provides a true statement, we will say yes, it is a system. Once again, just like the last one, if it's a no, we will say it's not a solution. So I'm going to continue to use that same ordered pair, 4, 2. Anytime I see an x, I'm substituting a 4 in its place. Anytime I see a 2, I'm substituting anytime I see a y, I'm substituting a 2. So it says 2x. What's that mean? It means 2 times x. X is 4 plus y. Well, y is just by itself, so I can just put 2. Equals 10. And then use our calculator. Just type this in. 2 times 4 plus 2. And that gets us 10. And does 10 equal 10? And that is another yes. So because I got yes, it was a solution for both. It is 4, 2 is a solution for this system of linear equations that works for both. All right, moving on to a different topic. Not topic, I guess, but different idea. So new directions. Solve each system of linear equations by graphing. Find where the 2 lines cross and write that point as an ordered pair. So there are 1 and 2. There are 2 equations. We must plot both of those points, plot both lines, and then wherever they share a common point is going to be our answer, whatever that ordered pair is. So I'll kind of color code this. This one will be blue. Actually, I'll do this. This one will be blue. Bottom will be red. Okay? So all we're going to do is make our line for the top equation, y equals negative x plus 3. In order to plot a line, we need to know what our y-intercept is and our slope, okay? Our y-intercept is the number by itself in this blue one. It is 3. And our slope is negative x. Well, it's the number in front of x, which would be a negative 1. So our slope is negative 1 over 1. So we go from our y-intercept, down 1, right 1. And like our bell worker, we're going to want to plot a lot of these points, okay? So we got to keep going. Down 1, right 1. Just keep doing that quite a ways. And we know we can also go another direction. Instead of down and to the right, we can do the exact opposite because that line extends upwards as well. It can go up and to the left, up and to the left, up and to the left. Okay, so that's what our line looks like for the top equation. Now in the bottom equation, I'll write this one in red. Our y equals x plus 1. Once again, if I'm going to plot a line, we need to know our y-intercept and our slope. Our y-intercept in this case is 1. It's a number by itself. And it's positive, so it's above 0. Our slope is what is in front of x. We could sneak a 1 in there, right? So it's positive 1 over positive 1. So I'm going to go up 1 and to the right 1. And I do not need to plot any more points because that was the point at which both points shared a common place. So that is our solution, where both points cross, okay, or two lines cross. So that ordered pair is what we need for our answer. What is our x comma y? So if I think, just always go back to the middle when you need your ordered pair. Start in the middle, 0, 0. You would go to the right 1 and then up 2. So x is 1, y is 2. Your answers are going to be an ordered pair. Put parentheses around them. Do not put these as a fraction. We're not finding slope. We're finding what our ordered pair is. Okay, we'd go right 1, up 2. So our x is 1, our y is 2. So the point where both lines cross is 1, comma 2. All right, moving on. Okay, I'll continue to color code. We'll go red here and blue here. Okay, so what is our y-intercept in the top equation on 4? It should be negative 1. Our slope is what is in front of our x. We could sneak a 1 in there, 1 over 1. So we're going to rise 1 and run 1. Rise 1, run 1. Remember, we're just going to do that quite a bit of times. And then our slope, or our line, also may go in the other direction. Instead of up 1 and to the right 1, the exact opposite could be down 1, left 1. That line extends in both directions. So there is our line for the top equation. Now the bottom equation, it says y equals 4. This is one of our special equations. If it's just y equals a number, it means our slope is 0, which means my line will be a horizontal line. And where are we going to put that horizontal line? Where y is 4. Y is 4, up 4. And then because it's just y equals 4, our slope is 0, it is a horizontal line. And now we're going to locate the point that both lines intersected or crossed, and that point is right there. So our answer will be whatever the ordered pair is to that box that I just put on your notes. X comma y. Our x is 5, right? We went right 5. Our y, we have to go up 4. 1, 2, 3, 4. So it's 5 comma 4. Remember, you're writing these answers as an ordered pair, not a fraction. Okay, moving on. All right, y equals 4x plus 4. That is, I'll do that one in purple, and we'll do this one in red. Y equals 4x plus 4. So we got to plot our y-intercept, which is 4. And our slope is 4. So we can write 4 as a fraction as 4 over 1. So from there, I go up 4, right 1. And if I kept going up 4, right 1, it would take me off the graph. So I probably don't need to keep doing that. But remember, our slope may also go in the opposite direction. Instead of up 4, right 1, we could go down 4, left 1, down 4, left 1, down 4, left 1. So there is our line for the top equation. Oh man, I did the color code wrong. Sorry about that. My colors here, I'll just do this. The top one should be in red, and now I'll put the bottom one in purple. All right, so now the bottom equation, y equals negative x minus 1. So we graph our y-intercept first, that's minus 1. So we go down 1. And then our slope was negative x, which means negative 1, right? We could sneak a 1 in there. And what's negative 1 as a fraction? Negative 1 over 1. So from our y-intercept, we go down 1, right 1, down 1, right 1. If I notice, though, if I keep going down 1, right 1, that's not going to take me closer to that top line. So I'm going to stop, and I know my slope may go the other direction. Instead of down 1 and to the right 1, it could go up 1 and left 1. And there is our ordered pair, or there is our solution. So we have to write that as an ordered pair. I would say negative 1, comma, 0. My x is negative 1, my y is 0. All right. Moving on, number 6. So I get the color coding right this time. Purple and red. We'll switch it to purple right away. All right, so we got to graph our y-intercept first for that top equation. Y equals 2x minus 4. So we need to go down 4 is our y-intercept, negative 4. And then our slope was 2. So we go up 2, right 1. And our slope may also go in the opposite direction. Instead of up and 2 and to the right 1, we go down 2, left 1. Okay, that is our line for the top equation. All right, now the bottom equation, y equals negative 1/2 x plus 1. Plot our y-intercept first. That is plus 1, so we go up 1. And then now we need to plot our slope. And once again, our slope was negative 1 over 2. So our slope is negative 1 over 2. So from our y-intercept, that red dot, I'm going to go down 1, right 2. And our points already overlapped. So there is our answer. There is our solution. That position as an ordered pair is x is 2, y is 0. So 2, comma 0. All right. Moving on. Okay. Number 7, y equals negative 3 over 2x minus 4. Find your y-intercept first. That is minus 4 or negative 4. And our slope is negative 3 over 2. So from that point, we're going to go down 3, right 2. Down 3, right 2. And our slope may also go in the opposite direction. Instead of down 3 and to the right 2, it may go up 3, left 2. Up 3, left 2. Up 3, left 2. 3, left 2. Give me a second here. Make sure I'm plotting this right. Oh, I caught a mistake. All right, here we go. Up 3, left 2. I only went left 1 there. Up 3, left 2. Up 3, left 2. Okay. And then now we need to plot x equals negative 6. Well, here's a special equation where it's just x equals a number. If it's x equals negative 6, our slope is undefined, which means I have a vertical line. And we put that vertical line where x, this time x-axis, is negative 6. So we put a vertical line through that point. And that is where they would touch right there. So we write that as an ordered pair. Our x is negative 6. Our y is 5, up 5, negative 6, 5. All right, okay. All right, I'm gonna skip 7. We're gonna go to number 8. If you guys wanna go back and do 7 on your own after we get, or sorry, I'm gonna skip 8, I'm gonna go to 9. I'm gonna skip 8 and go to 9. If you guys wanna go back and do number 8, you can when we are done with these notes. We'll do 2 more. All right, y equals x minus 1. So our y-intercept on this top equation is minus 1. So I put my first point down 1. And if it's just x by itself, we could sneak a 1 in front of that x. And to make 1 a fraction, we'd put 1 over 1. So I'm going to rise 1, run 1. Do that a few times. Rise 1, run 1. And our line may go in the opposite direction, as in down 1, left 1. And then now we'll do the bottom equation, y equals 3/4 x. The first thing we have to plot is our y-intercept, the number by itself after the 3/4 x. There is not a number, so my y-intercept is 0. If you don't see a number after your x, your y-intercept is 0. So put your dot at 0, 0. And then from that point, we need to do what our slope tells us to do. What is the number or fraction in front of the x? It is 3/4. So I'm going to rise 3, run 4. And I already have my spot where the two lines touched. So my solution is x is 4 and y is 3. And last one, okay? X equals y plus 1. You have to be careful on that one. You are not allowed to graph this unless your y is by itself. Okay, it's not in slope-intercept form here. So what we need to do is we need to get y by itself. So if I'm just looking on the side that has our y, it's the right side here. It's y plus 1. Think of it as a one-step equation. If you're to get y by itself, all you would have to do is get rid of the positive 1 by subtracting 1 from both sides, right? So those would cancel. You get y by itself. And then now just write this in your linear equation form. You can't actually take x minus 1. They're not like terms. So you just have to put them side by side. We always usually put our x term first because that represents slope. So what did I see on that left side? It was just a normal x. And then what do I see here? It is a minus 1. So now we took that equation and turned it into our linear equation. Y equals x minus 1. So now we can graph that. So our y-intercept on that one is negative 1. So I'm going to go down 1. And our slope is x, right? What's in front of the x? 1. So I can put 1 over 1. So I'm going to rise 1, run 1. Do that a few times. And our slope may also go in the opposite direction, down 1, left 1. So there's our line for the top equation. Remember, you had to solve for y first. You can't graph it unless y is equal to something. All right, and the bottom one, y equals 2/3 x minus 1. Well, our y-intercept is minus 1. And my slope is 2 over 3. So I could rise 2, run 3. Now, if you notice that, both of those equations had the exact same y-intercept. They both were negative 1. I put a red and a purple dot right there. So I really don't need to keep going because that is my that is my solution. That is where both points cross. If your y-intercepts are the same, there's your answer. Okay, they both touched where y is negative 1. So now all we have to do is write that position as an ordered pair. So our x, how far left or right did we go from the middle? Well, we didn't go left or right at all. It's 0. Right? And then we went down 1. So 0, negative 1. Those are the solutions to your notes. So now all you have to do, if you want to go back and do number 8, you can. You got bell work. Sorry, we already did bell work. You have your exit ticket. And then once you complete your exit ticket and get it checked, you are able to start working on your homework.